Okay, welcome back. We are on day three of our social distancing work, and today we're working on equivalent expressions, but specifically, we are going to be working with properties of exponents. And so, as you begin your assignment, the first thing you're going to be asked to do is review what we worked on previously, which is the fact that roots imply fractional power. That's actually a property of exponents. And so, if you have a square root, that is the same thing as a 1/2 power. If you have a cube root, that is the same thing as a 1/3 power. So roots imply fractional powers. In addition, you're going to be using the distributive property, distributing multiplication to an entire quantity. But the bulk of your work is going to be with regards to properties of exponents. And the way I'm going to teach this is I'm going to be using a song and a dance. And I put the dance in quotation marks because most of the time when I dance, people ask if I need medical attention. So anyway, I made a promise that I would always teach this way. I had a girl in class who came up with this dance, and the deal was is if she could come up with a dance every time I taught this, I would have to use the dance. So true to my word, this is going to be on YouTube for posterity. Will probably be shown at my funeral. So anyway, properties of exponents. So before we begin, we need to understand what we're talking about here when we go through the song. And when we have an expression such as x to the 5th power, the expression here has two components. The x is what is called the base, and the 5 is what is called the power, or exponent. So understanding what we're referring to is going to be a big part of understanding the concept. We have a base and we have a power. So if we were to use that base and that power, what x to the 5th means, exponents are shorthand for multiplication. And so instead of writing x times x times x times x times x, we would just write x to the 5th power. But x to the 5th power does in fact mean x times itself, times itself, times itself, times itself. 1, 2, 3, 4, 5. That's x to the 5th power. X to the 3rd power means x times x times x. And so when we actually multiply these, this becomes x to the 1, 2, 3, 4, 5, 6, 7, 8. And so this is just x to the 5 plus 3 power, which is x to the 8th. When we do division, x to the 5th, again, is x times x times x times x times x over x to the 3rd power, which is x times x times x. And when we divide these, what we're going to do is we're going to cancel. And so one of these x's cancels, another x cancels, another x cancels, and that leaves us with x to the 5 minus 3, because canceling takes it away. We took away 3, which gives us x squared right up here. If we divided the other way, it would work the exact same way. If we had x to the 3rd on top, x times x times x, over x to the 5th on the bottom, we would still be canceling. So x to the 5th expanded is x times x times x times x times x. Once again, we're going to cancel out 3 of them. Cancel 1, cancel 2, cancel 3. And that's going to leave me with 1 on top and x squared on the bottom. Now, if we kept to the same idea here that we took away, this would be x to the 3 minus 5, which is x to the negative 2nd power. And this is another big idea for properties of exponents. Negative powers don't mean negative numbers. Negative powers mean the exponent is a part of a fraction. And so when you have a negative exponent, you take it to the other side of a fraction bar. And then lastly, if we take a power and we raise it to a power, this is the same thing as saying x to the fifth 3 times over, times another x to the fifth, times another x to the fifth, which gives us in total 5, 10, 15. So when we raise a power to a power, that's going to be x to the 5 times 3 power, which is x to the 15th. And so that brings me to our song on how we remember the properties of exponents. So it goes to the tune of She'll Be Coming Round the Mountain. So it goes a little something like this. When you multiply same bases, you add. When dividing same bases, you subtract. If the exponent is negative, you take it to the other side and a power to a power multiply. When you multiply same bases, you add. When dividing same bases, you subtract. If the exponent is negative, you take it to the other side and a power to a power multiply. And so I taught that way, and this is where the deal came in. Now I have to teach it using her dance. I do not need medical attention. I'll just go ahead and say that. I'm perfectly fine. I'm not having a seizure. You ready? Can't believe I'm putting this on camera. All right. I'll go slowly the first time through. When you multiply same bases, you add. When dividing same bases, you subtract. If the exponent is negative, you take it to the other side and make it positive now. Because when it goes to the other side, it becomes positive. And a power to a power multiply. Now full speed. When you multiply same bases, you add. When dividing same bases, you subtract. If the exponent is negative, you take it to the other side and a power to a power multiply. And that is our property of exponents. So, next thing we're going to do is we're going to put it into action on an example problem. All right, here we have a question, and the first thing that you're going to notice is that when we simplify this, this looks really difficult. We have x to the fourth, y cubed, z to the fifth, times x squared, y squared, z, all over x cubed, y to the seventh, z to the sixth, raised to the fourth power. Gross. So the good news is that we're just going to walk through our song in order to simplify this. So, when you multiply same bases, you add. So we are up top multiplying. And so since it's multiplication, our same bases, all we have to do is add the powers. 4 plus 2 gives us x to the sixth. 3 plus 2 for the y's, because those are our same bases, gives us y to the fifth. And then 5 plus 1, okay, that's z to the first power, if it's just z, gives us z to the sixth. So now we have x to the sixth, y to the fifth, z to the sixth, all over x cubed, y to the seventh, z to the sixth. Next step in the song. When dividing same bases, you subtract. So we are going to subtract x to the sixth over x to the third. 6 minus 3 is 3. 5 minus 7 is negative 2. And z to the 6 over z to the 6 gives us z to the 0. Okay, guys, anything to the 0 power is just 1. So what we're left here is x cubed, y to the negative second, z to the 0 is just 1, And all of that is being raised to the fourth power. Okay, all that's to the next to the fourth power. And so, right here, if the exponent is negative, you take it to the other side and make it positive. So we have x cubed over a y to the positive second power. This does not mean y is negative. It just means it's on the other side of the fraction bar. All raised to the power of 4. And a power to a power multiply. So 3 times 4 is x to the 12th. 2 times 4 is 8, right there. And so that's how we do this. That's working through a question. This is a much more simple way of writing this expression. And so working through the song teaches us the properties of exponents. So big ideas. When you multiply same bases, you add the powers. When dividing the same bases, you subtract the powers. If you have a negative exponent, that does not mean a negative number. It means you take it to the other side of the fraction bar and change the exponent to a positive. And when you take a power and raise it to a power, you multiply those powers. That goes along with anything to the 0 power is 1. So that doesn't matter if it's 7 to the 0 power, that's 1. Z to the 0 power, that's 1. Pi to the 0 power, that's 1. Anything to the 0 power is 1, not 0. Easy mistake to make. And then lastly, going back into what we talked about last time, radicals are fractional powers. So a square root is the same as raising something to a 1/2 power, which means we could use that same idea and take the square root of this, x to the 12th over y to the 8th, and that would be, this would be the same as x to the 12th over y to the 8th to the 1/2 power. And so this takes us right back into our properties of exponents. It takes us from radicals to properties of exponents. And the power to a power multiply. So 12 times 1/2 is 6. 8 times 1/2 is 4. And so what we end up with, x to the 6th over y to the 4th. All right, guys, as always, if you have questions or trouble doing the work, please comment below. Just comment below this video. I'll respond to your comment as soon as I can. And like I said, I can always upload a picture of a problem worked out or create another video to reteach if need be. All right, guys, good luck. If you've got questions, just comment.